T6 Summer 2013, Paper 1, Non-Calculator. When we're asked to draw an appropriate straight line, we're actually being asked to solve two equations simultaneously. We have the graph x cubed minus 3x minus 4, so we want to know when it meets the line y equals 3x minus 5. So to draw that, we need to have 3 points. When x is 0, 3 times 0 minus 5, that gives us minus 5. X is 1, 3 take away 5 gives us minus 2. When x is 2, we have 6 take away 5, which gives us 1. Drawing the line, what I then need to do is find the points of intersection. And we have 1, 2, 3. First one is when x equals approximately minus 2.5. The second, x equals approximately 0.1, possibly 0.2. And the third one is when x equals approximately 2.4. We have the graph x cubed minus 3x minus 4. Yet we want to solve x cubed minus 4x plus 1. Well, that means we would have to take away x to give us minus 4x, and we would have to add 5 to get plus 1, and we want to know when that equals 0. So that is when our graph equals x minus 5. So the line that we want to draw is y equals x minus 5. When two shapes are similar, it means that one is an enlargement of the other. So we're interested in the scale factor. So we have cylinder A and we have cylinder B. Base radius of cylinder A is 5 and the radius of cylinder B is 10. That means that there's a scale factor of times 2 for their lengths. Volume is a length cubed, so the volume scale factor will be 2 cubed, which is 8. So if the volume of cylinder A is 60, then the volume of B will be 60 times 8, which is 480 centimetres cubed. To change a recurring decimal into a fraction, I'm going to start by writing out the recurrence. And it's important to note here that the dots only recur the 8 and the 2. Because the recurrence involves 2 numbers, if I multiply by 100, then the recurrence will stay in the same place. So if I subtract these two terms, the recurrence here will cancel out. So 100x minus x gives me 99, and 18.2 minus 0.1 gives me 18.1. So x is 18.1 over 99. That's an improper fraction. So can't have decimals, so I'm going to multiply top and bottom by 10. 181 over 990. So that leaves me with x equal to 181 over 990, and at the start we said that that was 0.182 recurring. There are a number of different ways to attempt this question. First one I'm going to look at is using a tree diagram. So we can have a P, an E or a T. Probability of a P 4/12, E 6/12, and T we then want 2/12. After the P we can get a P, an E or a T. I'm not going to look at the probability of a P because I already have a P and I don't need another one. Important to remember here, we have lost a tile. So we still have 6 E's, but we only have 11 tiles to pick from. We still have 2 T's, but we only have 11 tiles to pick from. After the E, we could have a P, an E, or a T. Again, we have an 11 tiles. We're interested in getting a P, so that would be 4/11ths. We're not interested in an E, but we are interested in a T, which is 2/11ths. Finally, down at the bottom, we can have a P, an E, or a T. Probability of a P would be the 4 that are left out of 11. An E would be 6 out of 11, and we can ignore T. Now this time we're going to work along the branches P, E, so all I'm interested in now is a T. I have 10 tiles left and 2 of those are a T. So the probability here will be 4/12ths times 6/11ths times 2/10ths, which gives me, when I cancel the 4 and the 12, give me a 3. 3 goes into 6 twice and 2 goes into 10 5 times. So that gives me 2/55. If I go along my next branch, I have a P and a T. So I need an E. And I have 6 of those out of 10. So I'm going to have 4/12ths, 2/11ths, and 6/10ths. And what I notice here is that the 3 numerators are always going to be the same. The 3 denominators are always going to be the same. So I'm always going to get 2 out of 55. So if I count up the number of times that options I'm going to have, PET, PTE, EP, T, ETP, TPE, TEP, and I can see that I have in total 1, 2, 3, 4, 5, 6. So my answer is going to be 6 times 2/55, which is 12/55. An alternative method would have been at the start to consider P, E, and T. Probability of getting a P in the first try, 4/12. In the second try, getting an E, I have 11 tiles left because I've removed 1, 6. And in the third try, the 2 out of 10. And using the same manipulation, I'm going to get 2 out of 55. Could have picked a P, then a T, then an E. E could have gone first, followed by P and T. E, T, P. T, P, E, or T, E, P. So I have 6 times 2 out of 55, which is going to get me 12 out of 55. If the area of a rectangle is 60, that will be x times 4√3. So to find x, we're going to want to do 60 divided by 4√3. The first thing I'm going to do here is 4 goes into 60 15 times. So I have 15/√3. Now we're not allowed to have a surge on a denominator, so we're going to rationalise it by multiplying top and bottom by √3. And that gives me 15√3 over the square root of 9. So that's 15√3 divided by 3. And finally I cancel the 15 and the 3 to get 5√3.